first period I started as statistics, and last period I did the probability, and today's probability distribution. Probability means that the definition is a chance of likelihood. This is the probability definition. This is a chance or likelihood. Chance or likelihood means that event can happen. So the chance to happen that event. This is we call the probability. Okay, so we can see that there is a twin number. This is the electric clock. This is clocks that start from the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 also. So this is the electric clock. So electric clock is moving at the time that you press the stopwatch to stop the clock. Okay, there are the chance to stop between the 5 to 9. We want to calculate chance to stop the watch between 5 to 9. So what will be the chance? So that you can count how many are total division. Total division will be the 12 division. Okay, 5 to 9 is a 4 division. So there are the whole clock. You can see the 12 division on the whole clock. So between 5 to 9, there are the 4 division. So the probability will be the 4 divided by 12. This is the probability. So this is the probability happen between the 5 to 9 is equal to 4 by 12. So this is kind of 1 that. So this is the probability 1 that. So this is the whole clock is moving. So between 5 to 9 you want to stop the clock. In this case probability can be the 1 to 9. So this is the 1/3 of the chance that you can stop the watch between 5 to 9. So this one we can also draw on the graph. How to draw the graph? The whole graph is represented. The holes are K. So this start from the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there's a scale will be the 12. So between 12, you stop between 5 to 9. So we draw that as 5 to 9. So this is a 5 point and a 9 point. And we draw and we shape. So this is a probability graph. So the probability graph will be there. This graph can change between the 5 to 9. So this is just the example. In real matter, events are very complicated. And also the possibilities are different. So normally we can draw the probability graph. Can be like this kind of shape. So this is the chance between here. This is the probability graph. So horizontal is the X, vertical is the gamma X. So this is the probability graph. Horizontal X, the chance to happen is the gamma X, the vertical. So that there are 12 scales. So between 5 to 9, you can sort of what? So this graph will be the probability graph. So this is for the big example. But in real practically, in the real practice, all the probability graphs are different shapes. So this is the shape thing, so this will be the probability graph. Okay, the next one will be the normal distribution graph. Normal distribution. So normal distribution graph, we can firstly you have to calculate the standard deviation. Standard deviation is this formula. Standard deviation. The standard deviation formula is a delta is equal to square root of summation S8 square minus N H bar square divided by N minus 1. So this is a standard deviation formula. This means how many events, for example, this event 1. Event 1 can happen at 5 times. Okay, event 2 can happen at 3 times. So event 3 can happen at 4 times. So this is the event. Event means for example, that you count the people. Some people you can see that some person. So you on the front row you count the people. Some you can see the male, some will be the female. So how many times they coming out? So this is the event 1. So event 1 5 times, event 2 3 times, event 4 4 times, event 3 4 times. So this means those events are represented by the age, and number of times is represented by the frequency. Multiply frequency. So multiply with frequency and the age. So this is and then you add all together. So you got the summation. And also you can also find the mean. H bar means the mean. Mean means that this is the average value. Okay, H bar is the mean or average value. And it's a total number of times. Total number of time. So those are the statistics data. So you can calculate the standard deviation. Standard deviation means how different from the mean. Any number can be different from the average value. So this is we call the standard deviation. How much the number differ from average value. This is we call a standard deviation. So standard deviation is how much the number differ from the average value is standard deviation. So that this is standard deviation you can calculate. So even number is a 1 2 3. So this is the H, frequency is the F. So the standard deviation equation you can calculate summation of Fh square minus N multiplied H bar square by N minus 1. So this is the standard deviation. So the standard deviation you calculate sometimes you can calculate standard deviation 2, sometimes you can calculate the standard deviation 1, sometimes you got the standard deviation 0.5. Those standard deviation we can draw the graph. So this horizontal represents axis. So this is the H. Vertical represent properly 8. So two graph. Some graph you got the graph like this. And one graph, another graph you got it like this. This is a graph like this. So every graph you got the same mean point. So this is the mean point is the same. So the top graph is you got the standard deviation data 0.5. This is you got the top graph 1. And the middle graph is data is equal to 1. And this bottom one is data is equal to 2. Second graph. All graphs we can see the probability. All probability graphs can be plotted in accordance with the standard deviation. They got the same mean. And their shape are like this. So those graph representation we call the normal distribution. Same mean. So this is you have the same mean. There can be the summation H1 by N1 is equal to summation H2 by N2 equal to summation H3 by N3. This is we call the normal distribution. So normal distribution graph, all the standard deviation graph, they got the same mean. Same mean, this is we call the normal distribution. So this is for the standard deviation calculation. Standard deviation means how much the number differ from the average value is. We call the standard deviation. So the standard deviation numbers are different. Standard 0.5, 1, 2 like this. So those standard deviation and the probability we get plot the graph. So in this case, those graphs you see that all are same means. Same means with the difference of standard deviation graph. So this distribution we call the normal distribution. And sometimes you can see the different mean and the same standard deviation. So we also plot another graph. Different mean and same standard deviation. So different mean and the same standard deviation can be plot. So those graphs are the same graph. This one will be the mu1. So this graph will be the mu2. So this one will be the mu3. So you see the graphs are the same size, but the means are different. So this is a different mean, same standard deviation. So that we can now only emphasize on the normal distribution. Normal distribution. Okay, normal distribution we can plot it. So how do you plot this normal distribution? They call this pear shape. Normal distribution is pear shape and a symmetrical. Symmetrical means the left side and the right side it can be fold together. So this is for this is normal point is the mu. So this one will be the delta. This is delta. So this is 1 delta. This is 2 delta. And this is the 3 delta. Also this one is a delta, 2 delta, and the 3 delta. So middle one is a mu. So this is a 1 standard deviation different, 2 standard deviation different, and 3 standard deviation different. So then we can see that this one. So between the data to the positive data to 1 data to negative data, probably between the mu minus data to mu plus data. Between the 1 data to 2 data, the total area will be the 68% of graph. So according to the mathematical experiment, we can see that for the normal distribution, between 1 standard deviation, so from the positive to negative, from the mean, 1 standard deviation, so those area contain the 68% of the whole area. So this is for the between 1 standard deviation. 1 standard deviation, that will be the 68% or 0.68. And then we can see that the 2 standard deviation. So 2 standard deviation is a mu minus 2 delta, and x is between the mu minus 2 delta to mu plus 2 delta. So in this case, 2 standard deviation, total area will be the 95%. So this becomes the 0.95. And also 3 standard deviation. So mu minus 3 delta. So x is between the mu minus 3 delta to mu plus 3 delta. So in this case, 3 standard deviation, total area connected by the 3 standard deviation cut is 99.7%. So 0.997. So this is the probability. So 1 standard deviation different, the area is 68%. 2 standard deviation different, area will be the 95%. And 3 standard deviation different, area will be the 99.7%. So in this case, we can write this area. The probability represented by the area. The area represented by the probability. So that from the mean is a 1 standard deviation different. Probability is 0.68. From the mean, 2 standard deviation different. Probability will be the 0.95. 3 standard deviation different. Probability will be the 0.997. So this is the number of chance to happening. The number of occurrence apart from it, away from it, the mean can be represented. The event, mu represent the mean, gamma h is the probability, and delta means the standard deviation. So X is how many events happen, and the probability is a chance. Mu is a middle value, and theta means that different from the middle value. So this is the IQ test data. IQ test data we want to allocate on the graph. So this IQ test data we can represent by the distribution graph. So this is the horizontal axis, this is the gamma x, so this is the x. So normally we can represent the graph like this. So this is the IQ test data graph. So this is we call it a normal distribution. So in this case, mean is 100. So this is the mu is 100. Mu 100 means this middle point. Middle point, mu is equal to 100. Okay, then we have to put the pin. So there will be the 68% of people got the IQ between the 85 and 115. 85 and 115 means the middle one is 100. So you can represent the 115. So this is the 115 here. Or this one is 85. So how much difference? So standard deviation is delta. Delta is equal to 15. So this is a 1 delta. This is delta. This is delta. Okay, so this becomes so this is feedback to the feedback for in this group will be the 68%. So this is 68%. So that we can write the big probability mu minus delta between the mu minus delta to mu plus delta. So mu plus delta is equal to 0.68. Because of the probability is mean is 100. So delta represents the 15. So that this is the 15 mean only one deviation. One deviation difference is 0.68. And another one will be the 95% and 95% of the people IQ between the 70 to 130. So the 130 here we can write here 130. 130 means this is a different is a 130 minus 100 will be the 30. So delta is 15, so the 2 delta will be 30. So this difference will be the 2 delta. 2 delta. So this is also 70. It's 2 delta. So difference between delta to 2 delta. So mu minus 2 delta and then mu plus 2 delta. So their probability will be there. So 95%, 0.95. So this becomes at 0.95. Okay, the next one will be the 55 to 145. So this is a 55 here. So this is a 145. So how much difference between the 100 to 55 and the 45? 45 means 3 delta. So this is a 3 delta. This is 3 delta. Also 145 minus 100 is a 45. 45 is represented by the 3 delta. So this is 3 delta. So in this case, total began at 99.7%. So that we can also write the equation. So probability between mu minus 3 delta to mu plus 3 delta. P mu minus 3 delta mu plus 3 delta is equal to 0.997. So this is that we can represent the probability by this way. So in this case, mean is 100. So the one standard deviation difference to the area is 8%. And two standard deviation difference to the area is 95%. Three standard deviation difference to the area is 99.7%. So you can write the thing P mu minus delta between mu minus delta to mu plus delta is 0.38. P mu minus 2 delta. So between the mu minus 2 delta and mu plus 2 delta is 0.95. And P between the mu minus 3 delta and mu plus 3 delta is 0.997. So the next one will be the Z score. Z score means the standard score. Standard score means that, okay, this graph you can see that 55, 70, 85, 115, 130, 145. So are the standard value, but the any value you can pick up any value here, you can pick up any one, and then you can substitute a formula. So this any value you can pick up on this graph is we call the raw data. Raw data means any data you can pick up. So between the range, any data you can pick up, this is we call the raw data. So in this case, we can calculate the probability. So this is we can calculate the standard score or the Z score is equal to, the equation is standard score or the Z score is equal to raw data minus mean divided by standard deviation. So this is the equation to calculate the standard score. So standard score is equal to raw data minus mean divided by standard deviation. So in this case, Z is equal to raw data is minus mean is a mu and standard deviation is delta. So H is minus mu divided by delta. This is the Z score. So in this case, H is greater than mu, so Z will be the positive. If H is less than mu, Z will be negative. If H is equal to mu, Z becomes a 0. In this case, there will be the no error. So those are the equation to calculate the standard score. So next problem, I will show you how to utilize it. So this is the example 21. Okay, so now we have to find the female height. The distribution of the female height, mean is U is equal to 165.5 centimeter. Standard deviation delta is 8 centimeter. So we have to find the standard score corresponding to the female height of 164. So in this case, this is a randomly used select the score. So this becomes 8. 8 is a 164. Then you need to calculate the Z. And also, when the H is at 178, you also need to calculate the Z. So the first thing we calculate, Z is equal to H is at 164. So the equation will be H minus mu divided by delta. So in this case, H is at 164, and mu all it got is at 165.5 divided by delta is equal to 8. So by solving this one, this is a minus 0.3. And similarly, you can also calculate the Z. So 8 minus mu divided by delta. So in this case, H is at 178 and mu is 165.5 divided by 8. So by solving this one, you got the 1.44. So this is the Z score we can calculate. So why we using the Z score? The main is a comparison. Comparison means that, for example, you want to compare the two people. So, for example, you want to compare the weight of the elephant and the weight of the snake. So, how you know? Elephant is very big, snake is very small. So, you cannot easily tell that the elephant is very heavy, snake is very small. But snake is got the two, they are standard weight. Okay. So, in this case, you can see that how many weight. So, people weight depending on the height. If you are higher, your weight should be there more. If you are shorter, your weight should be less. So by this way, you can take account on that your head. So if you are short but your weight is too big, in this case you need to reduce your weight. So this is why we'll make the comparison. So to make the comparison, we have to utilize the Z score. So Z score function is, there are people with the different people, different category, but anyway, you have to make the standard comparison. To make the standard comparison, we have to utilize the Z score. So the next program, we explain to it. Okay, this problem we want to compare the weight of the snake and the elephant. So we want to compare the weight of the elephant and the weight of the snake. But really, I see that roughly talking about elephant is very big, snake is very small. So you cannot easily directly compare. But but only you can compare with their relative weight. So relative weight you have to calculate. So that to calculate the relative weight, in this case, we have to utilize the Z-score. Z-score function is to make the comparison. There are two snake and elephant are different animals, but you can compare their relative weight. So because of this one, we have to utilize the standard deviation. Okay, so firstly, the weight of the elephant. Elephant is a mean is a 20. So that we can calculate the elephant. So mean mu is equal to 20 and standard deviation delta is equal to 2. So this is mu 1 is 20, delta 1 is 2. So in this case we have to see that the elephant. The elephant weight is at 23 times. So this H1 is at 23 times. So to make the comparison, we have to calculate the Z. So Z is equal to H1 minus mu 1 by delta 1. So the H1 is at 23, mu 1 is 20, divided by delta 1 is 2. So by solving this one, you got the thing is at 1 by 5. So this elephant Z score is 1 by 5. And also we have to calculate for the snake. So snake, for the snake got the mean is given as 30 grams. So this is mu 2 is 30. And also for the snake, standard deviation is 3 grams. So there are 2 is 3. Hello? For the snakes, mean is mu 2 is given as 30. And there are 2 is also the 3. So this snake got the weight 34 by 5. So H2 is equal to 34 by 5. Then you get to calculate Z. Z is equal to H2 minus mu 2 divided by delta 2. So that we substitute H2 is 34 by 5 minus 30 divided by 3. So this becomes 1 by 5. So Z also 1 by 5. So you see, the elephant Z score is 1 by 5. Snake also 1 by 5. So in this case, we can say that these two animals got the same relative weight. Same relative weight. So we can make the comparison. So two animals are different, but then we have to calculate Z score to make the comparison. So in this case, Z score is the same number for the same animal got the. So two animals got the same relative weight. Okay, now we want to make the performance comparison. So math, English, history, science. Those students got a score. There is a mean and a standard deviation. So we want to make a comparison. So how to compare? Math, science, English, and history are different subjects. So you cannot directly compare. For example, students get the higher marks in the math, but the lower marks in the English, because English is more difficult. Math is everybody got the answer, direct answer, get the 100 marks. But English, how you write, your writing, okay, or your grammar, how to use structure, the essay, everything have to use mark. So because of this one, English marks are not too higher as mathematics marks. So because of this one, only the thing can make the comparison is Z score. So you calculate the Z and compare the Z. So this is the only way to make the comparison. Okay, so now the only given for the marks only given for the math, English, history, and science. So the mathematics are student score. Student score is represented by the H, and mean is a mu, and standard deviation is a delta. So we have to calculate the Z. To make the comparison, they are the English, math, history, science are different subjects. So to make the comparison, you need to calculate the Z. So now we will calculate Z for the math. Z is equal to H minus mu divided by delta. So the H is at 170, mu is 150, and delta is 15. So by solving this one, you got the score is at 1 by 33. That is at 1 by 33. So English. So Z is equal to H minus mu divided by delta. So in this case, H is 120, mu 120, and the delta is 10. So we calculate this is 0. 0 is a normal. So this student got as a normal achievement. For the mathematics, 1 by 33 is called the beta. And history. So you calculate Z is equal to H minus mu divided by delta. So in this case, history score is at 188, main is at 200, divided by 12. So this is a minus 1. So minus means that this is a below the normal. 0 is a normal result. The student got this mark, this is a normal result. But positive means that this is a better than a normal. Minus means that lower than a normal. So that's science. So we calculate that. So H minus mu divided by delta. So in this case, sine H is given 120, mu is 100, delta is 8. So this becomes 2.5. So now you can make the comparison. You can order the comparison. So science is the highest one, and then followed by the mathematics, then followed by the English, and the last one we read history. So the student performance is he's got the best performance in the science because the score is a 2.5, and then also the mathematics also second the best performance 1.33. The English is the normal performance 0, but history is the most poor performance. So because score is a minus 1.0. So this is the probability for the not too difficult. So normal. First video I started statistics, and last video I give you the probability and. Okay, the next one is that we read the Z debate. So Z debate, I already given you this page. This one, this is the Z debate. Now we are using the Z debate. So as you did say that I show you the numerical calculation, then you are calculating, I calculate the Z. Z is equal to H minus mu delta, I substitute, make the calculation. This is the manual calculation. But really you can read on this debate. So this debate, this is the Z debate. So Z debate, firstly I give you the how to read the debate, and then I will use it, I will do the problem. So this is the Z debate here. So this is the Z0. This horizontal scale is 0.00, 0.01, 0.02, and 0.03 up to 0.09. So this is the case. And after that, this one particle scale is 0.0, 0.1, 0.2, go to the 1.1, and go to the 3.0, like this. So this is the Z table here. Okay, now we want to read the 1.12. 1.12. So how to read the 1.12? So you look at the scale on the particle range. Here you got the 1.1. 1.1. This is the 1.1 and 0.02. So 1.1 and 0.02, they will give the 1.12. So 1.1 plus 0.02. So 1.1 is here, and the 0.02 is here. So on the here, you can see 0.3686. So by the way, you can read this out. Number. So this number represents the probability. So Z0 is so Z0 is a 1.12. So this is 1.1 here, 0.02. So this is 1.12 is 0.3686. So similarly, if you read at 0.3686, then you can also interpret. So 0.3686 also equal to 1.12. So alternatively, 0.3686 is equal to 1.12. Sometimes you can't read the exact data. For example, sometimes you want to read the 0.3690. Okay, so 0.3690 you may not find in the data, but you have to use it the most appropriate. So 0.3686 is very close to 0.3690, so that you can still use the 1.12. Sometimes you can't read it directly on the data. In this case, you have to use the most nearest value. So that if you want to read the 0.3690, you can't read it directly, but it is close to the 3686, so that you can also use it. This is why also Z0 is 1.12. So this one represents the interpretation. So this means that this 0.386 is the area under the probability curve. So this probability curve here, measure is 0 and standard deviation is 1.12. In this case, the area covered by this one will be there. This area is 0.3686. So this is for the interpretation. So this is a measure is a mu is a 0. So delta is a 1.12. So the area cover under the value, under the curve from the 0 to 1.12 delta is equal to the 0.3686. So this is the interpretation. So the probability of the area under the curve, so from the mean to the one standard deviation, 1.12 is 0.3686. Okay, so we have to calculate the z equal to 0 to the z equal to 1.50. So alpha A is a p between z equal to 0 and 1.5. So you read the 0 value and you read the z 1.5 value. So on the scale you can see that 0 is equal to 0.00. 0.000. And 1.5, the 1.5, but you can see the 1.5, you see the 0.4332. 0.4332. So subtract from the higher to lower one. So the answer will be there, 0.4332. So the area between Z0 to Z1.5 is 0.4332. And second one. You have to find out the area between the Z0 and Z2.1. So Z0 to Z2.1. So in this case we just write P. So minus 2.1 is a smaller. P minus 2.1. So Z is between the minus 2.1 to and the 0. In this case, so you substitute 0. Read that 0 is a greater. So 0 is 0. Minus 2.1 also minus. Because if you read the minus, firstly you read the 2.1. 2.1 is you get the 4821. 0.4821. The 2.1 is the 0.4821. So for minus 2.1 is minus 0.4821. 2.1 you read, 2.1 you read is here. 2.1 is the 0.4821. If the minus 2.1, then we minus 0.4821. So the 0 minus 0.4821. So this minus will be plus. So this is 0.4821. And C. So between the minus 0.30 and plus 2.25. So plus 2.25. So minus 0.30. So in this case, the function is P minus 0.30. So Z is between the minus 0.30 and plus 2.25. Okay, firstly you read the 2.25. So 2.2 is 0.4861 and the 5 is the 0.04878. So that you read the base. So 2.25 is 0.4878 minus. So 0.3. So read the 0.3. 0.3 is 0.1179. So this is the 0.1179 minus 0.3 means minus 0.1179. So 0.4878 minus 0.1179. So this becomes the 0.4878 minus becomes the plus and this becomes the 0.1179. So you add together. So this becomes the 0.6057. So the probability between the minus 0.32, that's 2.25 is 0.6057. Now E. To the right of Z equal to 1.95. So 1.95. So this means that P Z greater than 1.95. Right means the greater, left means the smaller. So that in this case, to the right of Z equal to 1.95 means Z is probability Z is greater than 1.95. So in this case, the equation formula is that if you see the distance, the formula will be the whole area minus probability between 0 to 1.95. So this is the equation. So probability z greater than 1.95 means the equation will be this, the whole area minus probability between 0 and 1.95. So in the probability curve, the whole area is ever 0.5. So those probability curve, the whole area is ever 0.5. And then we have to find the 0 to 1.95. Okay, P0. So P0 to 1.95 means we have to subtract the 1.95. So read the 1.95. 1.95 is 0.4744. 0.4744. 0 is 0. So this means 0.5 minus 0.4744. So this becomes 0.5 minus 0.4744 means, so this answer will be the 0.256. 0.0256. So this is the answer. So z is greater than 1.95, so probability is 0.0256. Okay, so E. E is to the left of z equal to 1.64. To the left of z equal to 1.64. So this means the equation with the P, z is smaller than 1.64. So this equation. So for the left, you have to use the equation. The equation will be that the whole area plus probability between 0 and 1.64. So this is the left. Right means that the whole area minus probability between z are 0 to 1.95. For the left means that the whole area plus probability between the z 0 to 1.64. So that the whole area is the ever 0.5. And probability between the 1.64. So the 1.64, you read that thing on the 1.64, so that will be the 0.4495. So 0.4495. So 0 is 0. So this is the 0.5 plus 0.4495. So that will be 0.9495. So this is the equation that greater means the whole area minus, less means the whole area plus. Okay, between 0.6 to the 1.8. So this is just write the thing. Probability between the 0.6 to 1.8. So read the 1.8 on the graph. Also read the 0.6 on the graph and then subtract. So that if you read the 1.8, you read the things of probability 1.8 minus probability 0.6. So you read the 1.8, so this becomes the 0.4641. So probability 0.6 you read, so 0.2257. So you calculate, so this becomes the 0.2384. So those are the applications. So you can calculate the Z value by using the Z table. Okay, this equation if the 37.7% of population is a standard score between the mean and some positive Z value, you have to find the Z value. In this case, 37.7 is already given the Z area. Area is given 37.7, so percent, so 0.377. So 37.7% is the same as 0.377. So you have to find a Z. So on the Z table, you look through the 0.77 and then you can find the Z. So that you look through the which way is 0.377. 0.377, so you can see the 1.16. Because you see that 0.3770, so 1.1 and top will be the 0.6. So you can see the 0.3770. So here you can see the 1.1, the top will be the 0.06. So that will be the Z is equal to 1.16. So this is for the area A. And the B, find the Z value cutting off top 5% of the population. So cut off the top 5%. Cutting off top 5%. So if there's a problem given the cutting off the top 5%, in this case, cutting off means that you have to subtract from the whole. So the whole area is ever 5. So the whole area minus 5%. So the whole area is ever 0.5. 5% is 0.05. So 0.45. So this 0.45, you can also read from the table. So in this case, you can see that the 0. So you see that 0.4495 is here 1/6. Dot is 0.04. And also you can see that 0.4505. So dot will be the 0.05. Okay, so you can see. So on the table, you can see that 0.4495. So horizontal is 1/5. And vertical will be the 0.04. And 0.4505 is 0.05. So that you can write 0.4495 is equal to 1/64. 0.4505 equal to 1/65. So then you can make the average. Average is you have to make the. So 0.4500 is made between 4495 and 4505. So this is equal to 1/64 plus 1/65 divided by 2. So this becomes 1.645. So this is cutting off top 5%. We can calculate like this. And C. Cutting off the bottom 10%. So cutting off bottom 10%. Cutting off bottom 10%. So cutting off means that the whole area minus 10%. So equation. So this becomes the whole area minus 10%. So the whole area is 0.5 minus 10% is 0.1. So this is 0.4. So you read the 0.4. So on the table that you can't see the 0.4 directly. The most nearest value you can see is 0.3997. Okay, because you can't see the 0.4 exactly. Only that the most areas are closer one is 0.3997. So this is you can see the 1.2 and the 0.08. So this is a 0.3997 is horizontally the 1.2 and here is 0.08. So this becomes the 0.3997 close to the 0.4 is equal to 1.28. So Z equal to 1/2. On this scale, you can see. You can see that our points are 4 directly. The closest number to 0.4 is 0.3997. So 0.3997 will be there 1/28. 1/64. So this is 1/6. Horizontally 1/6. Vertically 1. So in this case, you can see that the distance points are 4, 5. 545, the closest number you can see is 0.4495 and 0.4505. 0.4495, you can see that 1/6 and 0.04 and 0.4505 is also 0.05. Another 0.05. And then you have to make the average. So 0.45 is average between. So we made the average. You also alternatively you can read the closer one. Either you can read the 1/64 or 1/65. They also correct. Either 1/64 or 1/65. But so you can take the two values. 1/5 is 1/5. In this case, you can make the comparison. Which one is the greater? The closer one. Okay, another one is find the value of Z so that the 95% of population is scored between minus Z and plus Z. So this one is this is a minus Z. This is a plus Z. So this is 4 between here. Okay, so minus Z plus Z. This whole thing will be there. This is a double area, 0.95. Okay, double area is a 0.95. But when you make the calculation, we only take the half area. We don't take the double area. So because of this one, this 0.95 is divided by 2. So this is a 2 area. 2 area is equal to 0.95. So the 1 area is equal to 0.95 divided by 2, so 0.475. Then this uses this 475 to read on the table. So then 0.475 Z. So you can see that 1.9. You can see that 0.475. 1.9 and 0.06. So that becomes 1.96. Z is equal to 1.96. Okay, so this is problem. The height of the adult bay in Austria has approximately normally distributed with the mean. The mu is 170 centimeter. So this is the normal size of the Austrian. And so standard deviation is the delta is 7 centimeter. So what is the population probability that may randomly set that has a height between 160 centimeter and 175 centimeter? This is greater than the 188 centimeter. So, firstly we have to calculate the mean. So, this is the firstly we have to calculate probabilities of 160 to 175 centimeter. So, this is the probability. So, P, so 160 is a minimum. So, that lies between the 160 to 175. So, you have to calculate. Okay, so, this P 160 to 165 you have to calculate. This means the area between. So this means the area between. So this 160 is the H1, 175 is the H2. Okay, so 160 is the H1, 175 is the H2. So to calculate this probability, this is the area between H1 minus Z equal to. So this is the area between. Z1 is equal to H1 minus mu by delta, and Z2 H2 minus mu by delta. So this is the property you can calculate. So in this case, 160 H1, 175 is H2. So we have to calculate the probability. Probability between the 160 centimeter to 175 centimeter. So this is the probability. So the can be calculated. So this probability is area between Z1 H1 minus mu by theta and Z2 equal to H2 minus mu by theta. So in this case, you have to substitute the H1 is 160, H2 is 175. Mu is 170, theta is 7. So we can calculate. Z1 is equal to H is at 160. So A is equal to 160 and substitute the mu. Mu is 170. So this becomes as Z1 is equal to 160 minus 170 and the theta is 7. And Z2 is equal to 175 minus 170 divided by 7. So this one you can calculate it. This is a minus 1.43 and 0.71. So Z1 is a minus 1.43, Z2 is 0.71. Then you can now utilize the area. Okay, so this is total area. This means this is a one is negative, another one is positive. Negative and positive means this is a positive 0.71, this is a negative 1.43. So how you find the area? This is you have to add. You have to add the total area. Because one is a positive, one is a negative. Because the one and negative they are the opposite side. Opposite side is between the zero line. So they are line between the both sides of the zero line. So because of this one, you have to add the area. So this area will be the area. So total is equal to area represented by the 1.43 plus area represented by the 0.71. Then you see the Z divided. Z divided is 1.43. 1.43 you use the Z divided. So you can see that 1.4 and 0.03. Okay, so the 1.43, the area is, you can see that 0.4236. And also 0.71. So 0.71, so you have to read it 0.7 and then 1. So another one is there. This is the 0.7 and 0.01. So 0.07 and 0.01, the area you can see is 0.2611. So those things you got it. So that now that the area will be 0.4236 plus 0.2611. So the total probability will be there 0.6847. So that the probability to find that Australian male, who got the height between 160 centimeter 175 in Australia is the 0.68.47% probability. And then there's 2. So 188 centimeter is the distance very short people. So in this case, that greater than 188 centimeter, so the probability you can calculate P greater than, Z greater than, A greater than 188. Okay, so this is the area so you can calculate. So this how you calculate? This is a greater. Greater is I already given you the once equation. Once calculation. Z greater than 1.95 is the whole area minus the area at the 1.95. So similarly, the P greater than this 1.188 is to the area. Okay, so H greater than 188 means we can calculate the total area. Minus, so this is the area under the area Z equal to H minus mu by delta. So the total area is 0.5. So Z you can calculate Z is equal to H is 188 minus mu is 170, delta is 7. So this becomes the Z is 2.57. Okay, Z 2.57 you read the area. So this is 2.5 and a 0.07. So you read at 2.57, so that area will be there 0.4949. So because of this one, 0.5 minus 0.4949. So that becomes 0.0051. So only the 0.5% to find the man with the taller than 188 centimeter. So you see that this is 160 to 175, that this is a normal height. But 188 is a very tall. So very tall people, you can't find very too much. So this is the thing. Okay, so number B. Greater height is by the 22% of the population. So in this case, area is by 22% of population can be calculated the whole area minus 0.22, and then you have to find the Z. So the greatest height is by 22% of population. So how to calculate? So in this case, the area, the whole area minus 0.22. Okay, so the greater height is by 22% for population means you have to find that the whole area minus 0.22. So that the whole area is about 0.5. So this is that the whole area is 0.5 minus 0.22. So this one you got is 0.28. Then you have to find a Z. So find a 0.8, 28, and have to find a Z. are stable, you can see that the 0.28. So you can see that Z will be the 0.77%. Because 0.7 is a 0.25. 2.8, so 0.77. 0.77 is a 0.2764. So this is close to the 0.28. Or 0.77, so 0.2794. So you can see that 0.07 and 0.07. So this is 0.2794. 2794, so this is very close to 0.08. So this is very close to 0.28. Therefore, so Z equal to 0.77.